Welcome to another exciting episode of Science. What we have here is our experiment looking at what happens to the temperature during changes of state. So what we've got here, we've got a beaker filled with ice and a little bit of water just to mix it up a little bit. Got a Bunsen burner and obviously the usual setup of a retort stand, gauze mat, tripod. Here, what we have is a temperature probe. Now this temperature probe is going to record the temperature every second of the experiment to see the accurate temperature of the liquid. So let's see what's going to happen here. Now what I've already discussed is that as the solid ice gets heated up, obviously then the particles separate, move around, and to become a liquid. During that stage, what we saw at the very start was that the ice was at 0 degrees Celsius, the freezing point of ice. Now, as the liquid water gets heated up, the temperature is obviously going to rise at a certain amount. Now we're going to see what happens also when the liquid starts to become a gas. So what's going to happen to the liquid energy of liquid particles as they go from a liquid state to a gaseous state. So let's see what magic we can see here. Now we are using a digital thermometer for accuracy purposes. Now, why is it accurate? One, there's no parallax error. The reading goes directly to the computer screen. Two, it's calibrated so that each change in degrees is exactly what's going to be here. So hopefully this will give us a very accurate reading of the temperature as it goes from a solid to liquid to a gas. Now we're going to see what happens here. So obviously at the moment, most of the ice has gone away. So we're going to bring it a little bit closer now. Now you can see with the graph here, it's gone up a little bit, but then there's little bits and dips there. Now why is that? What could it be? Now what you may see is that obviously as the ice is moving around, then that might change the temperature of what the sensor has at that moment in time. Let's just continue boiling it. As we can see, the curve isn't as good as it should be. It should be relatively a flat line going upwards, but let's just deal with it. So we've got on the heating flame here to see how we are going. It's rolling along quite nicely. It's about 125 mils of water now in this system. Now, because there's a little bit of ice left over, that would obviously regulate the temperature a little bit of it. It's continuing to go. So as you saw in the previous lesson, you saw graphs of this. So obviously at the very, very start of the graph, this point here, it's a flat line. Why is it flat? That is where the transition between a solid state and a liquid state is. So what should happen to the graph, to the temperature, as it goes from a liquid state to a gaseous state? That's what we're going to see in just a moment's time. Things do take time in science. That's how it works. So we just got to be a little bit patient here and think about what is happening there. Now, as you can see, the graph is going up at a relatively constant rate at the moment, which is good. So we can say that one of the errors is here, towards the start, was where you had the ice interacting with the liquid. So obviously, that changes things. So now, soon what we're going to do is to skip ahead to the finale. Bring this up closer so you can see what I am seeing. Be very careful and wow, isn't that amazing? Now this is what we want to see, a straight line here. This is what we saw the other day, a couple of weeks ago in our experiment, and so that's good. So there was something we could probably do again to smooth all that bottom bit out. So again, that's where we get reliable results by repeating it. Why do we repeat experiments? Because sometimes it may not be valid. And that is one aspect of where validity might come into it. You can see at the bottom of this program, it tells us the exact temperature to 1 decimal place. So the more significant figures and decimal places the measurement has, the more accurate our reading can become. Now at the moment, all the ice has melted and it's going up at a very nice temperature. There's the graph, there's the water. There's the graph, there's the water. So what we're going to do now is wait and see. It's come up to 89 degrees. So what should happen once it goes up to 100 degrees? Boiling, that's right, it's going to boil. And at the moment we can see gas particles are starting to rise up. That's the water vapor starting to be released from the bottom of the beaker up towards the top. So we're reaching almost the boiling state. So the process of boiling is occurring where it vigorously, with a lot of heat, changes the state of matter. And as you might see, is that there is some steam coming up. Steam all around the place. Now what is happening is obviously a lot of the liquid particles have got enough energy now to change to a gaseous state. Let's see, can you see that? Wow, so amazing. Okay, that's what's happening. So obviously the liquid now has enough energy for most of it to start changing into gaseous water vapor. What's happened to the graph though? Let's have a look and see. It has flatlined. And the temperature, 100.8 degrees Celsius. Excellent. Now that is what we expect. So is this an accurate experiment? I would say yes. Accurate, why? Because it matches up our value we have here of 100 degrees to our known boiling point of water. And it's continuing to go, continuing to go. And what you'll see is that the temperature is not changing. It's flatlining. So that means that the temperature of the water is not getting any hotter. It is exactly the same temperature. We've been boiling for about a minute or so now, but it's not getting any hotter. Now, why is that? The reason why that is because obviously, as we looked at before, particles have a force of attraction holding together. Now, because of that force of attraction holding together, you need energy to break apart that force of attraction. Now, what we see in the liquid phase, as it's going up, that energy from the Bunsen burner is going to make the particles move a lot faster and faster, and that is shown by the rising temperature. Now, what's going to happen once it goes from a liquid to a gas? That energy goes to separating the particles. So the temperature is a measurement of how fast the particles are moving. When they reach this stage, they're still moving fast, but they're just moving fast away from each other. Off they go as a gas. And that is how it works. We can keep going and going until it happens. So what's the temperature going to be? Still exactly 100 degrees until all the liquid has evaporated.